right? Let's get moving. Calculating the derivative at a point from the definition. So we start with calculating the derivative at a point. We have a function such as y equals x squared, and we need to calculate its derivative at the point x0 equals 2. So at that one specific point. Let's remind ourselves what the formula for the derivative of a function at point target is. I just copied it from the previous page, right? Here, you should already have it written down on a piece of paper and just substitute values into it. It's noted down. That's the formula. Now, we'll look how to disarm this, how to substitute it into this formula. x0, this specific point, in our example is 2, right? I substituted 2 for x0 in this formula. Got something like this. Let's think now. Equals, we rewrite the limit. I am rewriting this fraction bar, right? The function f at the point 2 plus delta x, what will that be? What will it be? It will be such a function. Here you have the formula for a function, in which the argument x is everywhere, 2 to the delta x. So here, you substitute x with 2 plus delta x. So here, in the formula, everywhere instead of x add 2 plus delta x. So if here it's x squared, then it will be the whole 2 plus delta x squared. And that is what it yields. Minus, I'm rewriting f of 2 everywhere here for this pattern. Replace x with what's in the bracket, in the vicinity, which is 2, so negative 2 squared. Divided by delta x, right? So, for this formula, using this data, you substitute, and we'll have the derivative from the definition. I'm squaring it. Based on the formula for abbreviated multiplication, of course. 2 squared plus 2 times delta x. Plus delta x squared. I'm not explaining where it came from. It's from my multiplication. Elementary, right? Minus 4. I'm doing a bit of cleaning up. 2 times 2 is 4. 2 squared is 4. It will be something like this. 4 minus 4 cancels out, leaving me with this. To calculate this limit on top, I factor out the common factor before the bracket. It will be delta x. This is such a method of calculating limits functions, often used, very popular. And look, it will look like this. When delta x is factored out at the beginning, delta x in parentheses. And from this component, as this component for delta x divided by delta x leaves me 4. And if I divide this delta x squared component by delta x, I'm left with delta x, right? It's something like this. And generally you factor out the common factor. AG, delta x. You take a bracket, open it, and insert here. What remains after you divide this component by what you've extracted. So you divide 4 delta x by delta x, and you get 4. Divide delta x squared by delta x, and you get delta x. Does the latex shrink, right? Do I get a limit from something like this? And here's an important thing. How was it with limits? You substituted delta x approached 0, right? So it approaches 0. What's left for me? 4, because 4 plus something approaching 0 is 4. 4 plus 0 equals 4 because it approaches 0, right? Calculated the derivative at this point. What does that mean? Referring to the definition of the derivative, it means that at this point, at 2, the function is rising quite quickly, not 4. So the values are, the growth in value is 4 times greater than the growth in arguments. It's sharply rising, the function at this point 2. When you draw this y equals x squared, it's like drawing a parabola. And you'd see that indeed, at 2, it's already speeding up significantly. At 2, in other points, it might have a different value. Here, I hope you got the idea with this factorization. We used some limit techniques here, but even without the concept of limits, this could be done. Someone might say, okay, so what? For delta x, we just took 0. Because here delta x approaches 0. And what? We got 4. So why couldn't we do this from the start? He took delta x0 for himself, and we'll see what comes out. See, if we took delta x0 here, that would give us 2 plus 0, which is 2 squared, is 4 minus 4. So it would be 0 on top, 0 at the bottom, 0 divided by 0. This is called an unspecified symbol. We would not know what it was aiming for. And that's why we had to use all these methods. Here 4 plus 0, we know it has to 4, no problem, but infinitely small number divided by infinitely small number. We wouldn't know what this leads to. And that's how it's done. Here are a few comments. Was it really hard? It wasn't hard, but has a tricky moment here with this insertion. For x to this formula, everything that's in the brackets. I'll be gradually doing it in other examples, translating to calculating the derivative from definition. There are just 3 or 4 formulaic. You do the same everywhere. So pay close attention in this lesson, do your homework and relax. I doubt anyone will surprise you with anything in class. Patterns repeat. That's what I wanted to say. Why? Because they're patterns. I emphasize the result, of course. Exactly, this is where it should end. Emphasize what your result is. The result is 4. At this point, the derivative is 4.